Hi. So second unit, flexural stresses and shear stresses. And this flexural stresses is nothing but bending stresses. So in this bending stresses, we have to derive the equation for bending equation. So bending equation is nothing but m by I is equal to sigma by y is equal to E by R. So that equation is very, very important for further studies and design of beams and all. So now we can see how to derive the bending equation. So if you consider the simply supported beam, when it's subjected to the load, it will be bent like that. So this is the nature of the bending, right? So you can consider the beam section before bending. So before the bending, you can consider the beam. This is the beam. So at middle there will be the neutral axis. So this point EF, this layer is EF, and you can consider another layer GH. Okay, at a distance of Y from this neutral axis, right? This is the layer EF and this is layer GH. This GH layer is at a distance of Y from the EF. Okay, so from the neutral axis, so this is the top layer and this is the bottom layer. So in between this center layer EF and the bottom layer, there will be another layer you consider GH at a distance of Y from the EF, right? Now consider the section or a beam after the bending. So after bending, so if the load is applying moment or load, if applying, so due to that moment or the load, the beam will be bent like this, right? So now this neutral axis layer is EF becomes E dash F dash and GH becomes G dash H dash, right? So if you consider the curvature with the point O, from this point O, this EF, the radius will be R, right? So R is the radius of curvature of the layer E dash F dash, and Y is nothing but distance from the neutral axis up to the layer G dash H dash. So this is distance from the neutral axis up to the G dash H dash. That is the distance Y. And theta is nothing but angle subtended by arc at the center. So this is the theta, angle subtended by the arc at the center. So now strain in the layer GH due to the bending. Due to bending, there will be strain in the layer GH. Okay. So GH layer strain will be E is equal to change in length divided by original length. So change in length is nothing but, so from the GH it becomes G dash H dash, right? Therefore the final length is G dash H dash after bending. Therefore G dash H dash minus the original length GH divided by the original length, because change in length divided by original length. Change in length is nothing but G dash H dash layer minus GH layer divided by original length is GH layer, right? Now, you know, GH is equal to EF, right? So here you can see in this, GH will be is equal to EF, right? Both layer are same. GH will be equal to EF. Therefore, instead of GH, here you can substitute EF. Therefore, G dash H dash minus EF divided by EF. Now the length of arc E dash F dash or EF is given by, here EF or E dash F dash is equal. Here you can see this E dash F dash is the neutral axis. So at the neutral axis there will be very less bending. So almost this E dash F dash will be is equal to the original length EF. Therefore E dash F dash will be is equal to EF, and this arc length E dash F dash or EF will be is equal to this radius into theta or theta, right? Therefore EF or E dash F dash will be is equal to R theta, length of the arc. Similarly, length of the arc G dash H dash. You can see G dash H dash. So this is E dash F dash. This is R into theta. So G dash H dash, length of the arc G dash H dash will be is equal to this R plus Y into theta, right? So here to here R and up to G dash H dash Y. So R plus Y into theta, R plus Y into theta. So the length of arc G dash H dash will be is equal to R plus Y into theta. So how can you written this? G dash H dash equal to R plus Y into theta. R into theta plus Y into theta, isn't it? So G dash H dash will be equal to R into theta plus Y into theta. Now, what is change in length delta L? Change in length will be is equal to G dash H dash minus EF, right? So here you can see change in length by original length. Change in length is G dash H dash minus EF after changing and before changing. That is change in length, G dash H dash minus EF. So that is the change in length delta L. So G dash H dash is nothing but R theta plus Y theta. You can substitute instead of G dash H dash R theta plus Y theta minus EF. EF is nothing but R theta. So EF is equal to R theta. So therefore plus R theta minus R theta get cancelled. Therefore delta L change in length will be equal to Y theta. Right? Now this put the value in the equation 1. So what is the equation 1? Equation 1 is nothing but E is equal to G dash H dash minus EF. That is change in delta L divided by EF. So now delta L is Y theta divided by EF is R theta, right? So change in length divided by original length. Here strain is equal to this delta L is Y theta divided by original length is EF. EF original length EF, that is R theta. So here theta get cancelled, therefore Y by R. Therefore strain is equal to Y by R. So E strain equal to Y by R. So you know very well from Hooke's law, stress is directly proportional to the strain. Therefore, stress is equal to Young's modulus into strain. Therefore, Young's modulus is equal to stress by strain, isn't it? So, instead of strain, you can substitute stress by Young's modulus. Okay, stress is directly proportional to strain. So, stress is equal to Young's modulus into strain. Therefore, strain equal to stress by Young's modulus. So strain is equal to stress by Young's modulus, which is equal to Y by R. So sigma, this Y come here and this E goes here. Therefore, sigma by Y is equal to E by R. So you got one equation. Sigma by Y is equal to E by R. This is the second equation. Now you can rewrite this equation. Sigma is nothing but bending stress. Isn't this? So bending stress acting in the layer sigma B will be is equal to E by R into this Y goes there. So E by R into Y. So this is the equation 3, where sigma B is equal to bending stress and capital E is equal to Young's modulus and capital R is equal to radius of curvature. So from this equation 3, we see that this Young's modulus and the radius of curvature R are the constant value. Therefore, capital E and R are the constant value and this will become vary based on this value Y. If the Y distance is increased, the sigma B also what will happen? Increase, because directly proportional. Okay, sigma B is directly proportional to the Y. Therefore, if Y is vary, increase, sigma B increase. Y is less, sigma B is also less, because sigma B is directly proportional to the Y. Okay, now consider the cross section of the beam. So consider the beam cross sectional rectangular, and in that consider an element of strip, small element you consider, having the area of dA, okay, and located at a distance of y from the neutral axis. This layer, small layer you consider, this will be at a distance of y from the neutral axis and it is subjected to the force dF. right? So the force acting on the elemental strip because of the bending is force dF will be is equal to force equal to what the formula? Stress into area. Stress equal to load by area, force by area. Force equal to stress into area. Therefore, dF will be equal to the sigma B into dA. So the small dF will be is equal to sigma B. You found it. What is the sigma B? E by R into Y. Sigma B is nothing but E by R into Y. You can substitute that one. Sigma B is equal to E by R into Y into dA. Right? Now taking the moment of force above the neutral axis. So the moment is dm, which is equal to load into distance. So dm is equal to from above the neutral axis. With respect to neutral axis, force into distance y, df into y. So if you take moment about neutral axis, df into y, right? So dm will be equal to df into y, moment equal to load into distance. So df value, e by r into y into dA. Df value e by r into y into dA, right? Into this y distance y, right? So now you can, this is differentiation of m. If you want to remove this differentiation, you have to integrate both sides, that d will cancel. Therefore, integrate both sides, you will get, so integration of dm will be equal to e by r into integration of y square into d, right? So e by r into y square into d, integration of. Now what is dA into y square? dA is nothing but area, y square means distance square. This is called second moment of area, isn't it? So area into distance square. So this is called second moment of area. Okay. So second moment of area is nothing but moment of inertia I. So moment of inertia I is equal to second moment of inertia dA into y square. Therefore, you can substitute this. Okay, here this d and this integration get cancelled. Okay, now both side integration get cancelled. Therefore, m is equal to e by r into this y square dA is nothing but I. So m is equal to e by r into I, where I is the second moment of area or moment of inertia about the neutral axis. Therefore, this I comes here, m by I is equal to e by r. This is another equation, m by I is equal to e by r. Now, what is the second equation? Sigma by y is equal to e by r. Sigma by y is equal to e by r. What is the fourth equation? M by I is equal to E by R. E by R is common. That sigma by Y here M by I. So if you equate this 2 from the equation 2 and 4, you will get the equation as sigma P by Y is equal to E by R is equal to M by I. Right? So sigma B by Y is equal to E by R is equal to M by I. Or M by I is equal to sigma by Y is equal to E by R, right? So sigma is nothing but sigma B. Sometimes they will call this bending stress as F, FB or F or sigma B. It is denoted as FB, sigma B, F. So M by I is equal to sigma B by Y is equal to E by R. This is the bending equation or flexural equation, bending formula or flexural formula. M by I is equal to sigma by Y is equal to E by R, where M is nothing but bending moment. What is the unit? Newton mm. Bending moment, load into distance. Load Newton, distance mm or meter. Newton meter, Newton mm, kilonewton meter, kilonewton mm. Like. And I is nothing but second moment of area or moment of inertia for the beam cross section. I is nothing but mm power 4. Suppose rectangular section. Rectangular section means, you consider rectangular section of the beam. So rectangular section means BD cube by 12 moment of inertia. B mm with D mm, D cube, mm cube. So mm into mm cube, mm power 4. So moment of inertia unit, mm power 4. And sigma B, bending stress, stress equal to load by area, load in Newton, area mm square. So Sigma B bending stress is Newton per mm square, and y is nothing but distance of the layer subjected to bending from the neutral axis. So from the neutral axis, because of the bending, how much it is, another layer. Okay, so distance of the layer subjected to the bending from the neutral axis is called y, mm. Distance is mm. E, Young's modulus or modulus of elasticity for the material. Young's modulus, stress by strain, stress Newton per mm square, load by area, strain no unit, so Newton per mm square. And R, radius of curvature of the beam, which is in mm, radius of the curvature. So this is how you have to derive the bending equation. So just to you take the simply supported beam, it is subjected to bending. So before the bending, the beam will be like that. This layer, neutral axis layer EF, and this layer GH. So after the bending, this will be bending like this because of the curvature. It will get the, if you take the center of curvature O, from this is radius point R, and this distance E, between E dash F dash and G dash H dash, distance is Y, right? So first you need to calculate the strain, that is change in dimension by original dimension. So change in dimension is G dash H dash minus GH, final length minus initial length. Here wrong, first final length G dash H dash after changing, then original length initially GH. So G dash H dash minus GH divided by original length is GH. So this GH can become EF, GH will be equal to EF, therefore G dash H dash minus EF divided by EF. So this is the strain, right? This EF is the arc length, will be R theta, length of the arc EF will be equal to R theta, and G dash H dash will be equal to R plus Y into theta, therefore R theta plus Y theta. So change in length, if you substitute these values, EF value, G dash H dash value, you will get the delta L Y theta. So delta L by L, original length, Y theta by R theta, EF. Original length is EF. Y theta by R theta, theta will cancel. Therefore, strain equal to E equal to Y by R. So here strain is nothing but stress by Young's modulus. So stress by Young's modulus is equal to Y by R. So this is the equation. And from this equation, you can write sigma B equal to E by R into Y. Okay, so sigma B is directly proportional to Y. E and R are the constants. Then if you consider the rectangular section, neutral axis, take the element DF strip, and the distance is Y from the neutral axis. So if you consider the force is equal to stress into area. So stress sigma B, already find out E by R into Y, dA, you know. So if you take the moment is nothing but force into distance. So force is stress into area, moment is force into distance. So force you already know, you substitute and integrate both sides and cancel the integrate with differentiation, and you can get the moment equation E by R into Y. So from this M by I is equal to E by R. So already you know sigma by Y is equal to E by R. So equate this, you will get M by I is equal to sigma by Y equal to E by R. This is the bending equation. Okay. So I hope you understand. Thank you for listening.